So hello all students, this is my second episode for Indices. For the first episode, we really went through the basic laws and there's certain information that we need to know to attempt indices. So for the first question that I've picked out is 27 to the power of 1/3 times 1/9 to the power of 2. Now for the first step, what I like to do is actually to make this fraction into a whole number, because fractions actually make student think that a question is more difficult than it is. So 27 over 1/3 times 1/9, you can bring 9 over to the numerator to give you a -1. So it's 9 to the power of -1. The next step, you actually realize that 27 and 9 are factors of 3. So you can rewritten 27 to be 3 to the power of 3, 1/3, times 3 to the power of 2 minus 1 times 2 gives you -2. So this is just multiplying these two first, and then you leave it outside. Now 3 to the power of 3 to the power of times 1/3 gives you 1. So therefore it gives you 3, and 2 times -2 gives you -4. Since these are the same base, you can add them up. When doing multiplication, this is actually power of 1. So therefore 3, 1 plus -4, which will give you 3 to the power of -3. Usually the question wants you to leave it in positive terms, positive powers, then that's okay. You can put it under the denominator, which gives you 1 over 3 over 3. And this will gives you 1 over 27. Alright, so we can see the mixture of the laws of indices being played out. Next question, a little bit similar. 3/4 to the power of -2 divide by 16 to the power of -1/2. Like I said, the negatives can bring it down, so it gives you 3/4 to the power of 2 divided by, now we want to reduce this such that it has something to the power of something, such that we can put it back into the indices form. So therefore 16 is actually 2 to the power of 4. Right? Now, one of the laws of indices states that we can actually bring the power to the numerator and the denominator. And we will do exactly that. 1, 3 to the power of 2, 4 to the power of 2, close bracket. And for this, 4 times -1/2 gives you 2, -2. Once this is done, you just compute your 3 square and 4 square, which gives you 9 over 16. This, make it positive, gives you 1 over 2 over 2. Now, let's settle this first. To not complicate things, this is basically 1 over 9 divided by 16. Division, you can swap this to be 16 over 9. When you have a division, the fraction or the second term will have to swap its place. So let's say if you have 1 divided by 2, 1 times 1 over 2, which gives you half. So this is what we're going to do. So it becomes 16 over 9. 1 divided by 2 squared, which is 1 over 1/4. So same thing as you done here. And this gives you 7, 1 over 9. Alright, so for the next question, part C. I have 1/4 to the power of 0 minus square root 64 plus half to the power of -3. anything raised to the power of 0, anything raised to the power of 0 gives you 1. So we know that this is 1. For a square root, the power can be rewritten to power half. Next one, we can make the power to be a positive power by placing it under the denominator. Same goes for the rest. You can see that here is a 2, and we know that this is a factor of 2, so therefore we can put it 2 to the power of 6 to the power of half plus 1. And remember what we did just now, where we actually introduced the power into the numerator and denominator. This is the same thing. So it gives you 1/3, 2/3. So 6 times half. So half of a 6 is 3, so it gives you 2 to the power of 3 plus 1/8. So we know that this is 1. 2 to the power of 3 gives you 8. 1 divided by 1/8 gives you a plus 8. And I'm going to say it again. For this type of fraction, do not overcomplicate things. Division is when you swap your numerator and your denominator, which gives you the answer. So 1 minus 8 plus 8, this is 0, therefore leaves you with 1. For the next question, we have cube root of 216 multiplied by 4 root 625. Cube and fourth, this simply can be rewritten as 216 to the power of 1/3 times 625 to the power of 1/4. If you can refer to my previous videos, I've actually went through how you actually change this square root into a fraction of a power. Now this is the tricky part. We need to know what are similar to these two, or whether do they have anything similar. In this case, there's nothing similar about 216 and 625. They are not multiples, or neither they are factors of each other. But to reduce 216, you can put it as 6 to the power of 3 to the power of 1/3. 625 can be rewritten as 5 to the power of 4, 1/4. And 3 times 1/3 gives you 1. 4 times 1/4 gives you 1. So therefore 5 to the power of 1 gives you 5. And 6 times 5 is simply 30. To the power of x gives you 1. Solve for x. Now, you know that any number raised to the power of 0 gives you 1. So we know that 25 to the power of 0 is actually 1. Thus, x gives you 0. Moving on to the next example, we have 4 to the power of 3x equals to 2. Now, we know that this 2 base has to be the same in order for us to compare. We know that 2 to the power of 2 gives you 4, which does not change its equation. And thus we know that this 2 times 3x gives you 2 to the power of 6x is 2. And this is 1 to the power of 1 because there's nothing over there. And we know that this is the same base, so we can actually compare straight to its power. And thus 6x is equals to 1. To find your x, you have to bring 6 over to the plus sign. And how you do that is actually you have to divide 6 by both sides. You have to divide 6 by both sides. So if I divide 6 by both sides, I divide 6 by both sides. 6 divided by 6 gives you 1. 1 divided by 6 gives you 1/6. And thus x This gives you 1/6. The next example is 36 to the power of negative half is 6 over 6x. So first thing first, we realize that all of these bases are 6 except for 36. And we know that 6 squared gives you 36, making all of this the same. And we know that this is 6 over 1 for its numerator, and its denominator is 6 to the power of x. When you have a division, your power will subtract, which gives you 6 to the power of 1 minus x. Now we simplify the left-hand side of the equation. 2 times minus 1 gives you minus 2. Since now both of the bases are similar, we can compare the powers. You have minus 2 equals to 1 minus x. Bringing over 1 over the equal sign will change its sign to become minus 2 minus 1 equals to minus x. Minus 2 minus 1 gives you minus 3. Removing, since you have a negative at both sides, you can remove the negative sign, thus giving you 3 equals to x. The last example I would like to go through for indices is 2 to the power of x times 4 to the power of x equals to cube root of 512. So usually you want to reduce the base to the smallest number. In this case, our smallest number is 2, and we know 2 to the power of 2 gives you 4. And for this case, you have to trial and error, but at the end of the day, 2 to the power of 9 gives you 512. So that's why we can actually change all of the bases to. So for the first part, before you change the base, okay, let me do this first. For a cube root, we know that it is the power of 1 over third. With the laws of indices, and therefore from here we can actually solve. You have a multiplication here, because 2 to the power of x gives you 2x. I'm just simplifying everything. 9 times 1 over third is 2 to the power of 3. 9 times 1 over third is 3. So now the entire equation has the same base. You can compare the powers. So x plus 2x gives you 3, and x plus 2x, this is an imaginary 1 over here because you don't really have to write it at the front. When it's 1, gives you 3x. 1 plus 2 equals 3x, and we have 3. And we know 3 divided by 3 gives you 1. And that is how you solve and make use of different types of indices laws for you to solve different questions. Thank you.